So geometers, we are going to find the surface area or use the surface area formula and the volume formula of a sphere and find a number of different things. But first, we want a little bit of vocabulary. So the first thing we're going to do is name a chord, and we need to define a chord, what a chord is. A chord is a segment whose endpoints are on the sphere. Notice instead of writing down sphere, I just pointed that. Why? Because the chord of a circle is the same thing. It's a segment whose endpoints are on the circle. So this one's not too crazy. So let's look at one here. There are at least two that I see here. One of them starts here at E, ends here at D. So, and this one says simply name a chord. So I'm going to say segment ED. However, had you said segment AB, that also will give you, because A is on the circle, or A is on the sphere, as is B. C is hanging out inside, so C is not going to be an endpoint. So had you said AB, segment AB here, you would be right as well. Okay, name a segment that is a radius of a sphere. So we're only going to write a radius, but AC is one. But had you written another one, it would be CB. All right, so name a segment that is a diameter, and dia means through, meter means measure. So the thing that goes all the way through, we've already named that AB, segment AB, because it cuts all the way through the circle, through the center. All right. Next, we're going to find the circumference of the great circle. And we've already defined great circle, but we need to define this as well. A great circle is the largest possible circle that is on. It's kind of like as if you put a rubber band around a ball. And where does that rubber band live? And in this case, this is a great circle here. Notice that if I tried to put a rubber band around this section here, it would pop off. So it would have to be the place where it rests. And notice that the center is going to be right there. So the center of the great circle is the same as the center of the sphere. So find the circumference of the great circle. That contains A and B. So circumference, of course, is just 2 pi r, and my radius. So interpreting that my radius is 3, because the midpoint of CB is right here, and 3 inches is pretty close to that. So all I do is substitute that in. So 2 pi times 3. My exact answer is 6 pi. And the approximate answer is approximately 18.85. And in this case, it is inches squared. Oh, not squared, because we're talking about a linear amount. So 18.85 inches. All right, so now let's get into the computational aspect. Surface area of a sphere. This one, again, is hard to prove. I think it requires calculus. We have to do limits, etc. But here is the surface area formula. 4 pi r squared. In other words, it's like 4 circumferences. That's it. 4 pi r squared. And the volume of a sphere is 4 over 3 pi r cubed. Which makes sense because volume is cubed. All right, so applying these special formulas into the context. The first one is a straightforward interpretation. We're given the radius. We just have to use the formula. So volume is 4 pi r squared. My radius is 4. So my exact answer here is 64 pi centimeters squared. My approximate answer would be approximately 201.1 centimeters squared. Both of these are answers depending on the context. All right, now finding the volume of the sphere is fairly straightforward. All we need to do is substitute and simplify. We only need one thing, which is very nice. All we need is radius. So volume is 4/3 pi r cubed. 4/3 pi times 4 cubed. The exact answer is 256 pi over 3 cubic centimeters, which is not a very helpful, nor is it a very clean answer. So that's in terms of pi. Now plug all that into a calculator to get your approximate value. 268.1 cubic centimeters. And we'll box or circle our answer to make it easy to find. Again, be in the habit of writing the formula down right when we use it, especially when we get down to 3 and 4, because we're going to start with the formula, but instead of substituting an R, we're going to substitute in volume or something. Anyone see a mistake here? It's a very minor mistake.
Which one?
Here. So this is not volume, but surface area. The next type of problem we want to find, and you'll find this often on a standardized test, MCAS or SAT or ACT, is they give us the volume, they give us the surface area, and you have to find the other one. So in this case, we're given the surface area, and they tell us exactly, it's not an approximate, it's exactly 121 pi. So the process that we're going to do is we're going to find the radius first, then once we have the radius, we can plug that back into the other formula appropriately. So I'm going to start with the formula just to be in the habit, 4 pi r squared. Now I'm going to substitute the 121 pi, and don't forget that pi. The pi is not a unit, the pi is a number. All that equals 4 pi r squared. Now I have to clean up the right side. To get r by itself, the first step I do is to divide by 4 pi. Notice that the pi is reduced to 1. Pi divided by pi is 1. So all I need to do is calculate 121 divided by 4. So I bring down the r squared, 30.25. Now, with your calculator, all you do is hit the square root button to find the answer. So R is 5.5. Notice I didn't say approximate. My calculator gave me that exact number, and usually the approximation is a result of a pi being approximated. But pi's aren't being approximated. They reduce to 1 here. So this is still going to be an exact answer. So I have my radius, ka-chow. So now I'm just going to take that radius and substitute into my volume formula over here. So volume of a sphere is 4/3 pi r cubed. 4/3 pi times parentheses 5.5 cubed. So the exact answer will be 665.5 divided by 3 times pi. Not a very clean answer, so it'll be cleaned up when we decimalize everything. 6272.2, and all of these are cubic feet. Again, both of these are good answers. So problem number 4 is the same as 3, except this time we're going to find the surface area given the volume. So, like we did before, I am going to start with my volume formula, which is 4/3 pi r cubed. Now the downside of this one is that we have to get rid of a fraction and a cube. So that's going to take a little bit of mathematical ingenuity. I'm going to substitute in the 1072 on the left side. I'm going to change this to an approximately value, approximately equal to. Now I need to get rid of two things. I am going to get rid of all this by multiplying by the reciprocal. What does that mean? The 4 is now below with the pi, and the 3 is on the top in the numerator. So, in other words, I'm going to, with my calculator, I'm going to multiply the 1072 by 3 and divide by the 4 pi. With the calculator, it's as simple as this. 3 times 1072 divided by 4 divided by pi. And that'll give me an approximate value for my cube. To get approximately 255.9. Now I need to cube root this. So let me just show you the notation for cube root in case it's been a while for you. Cube root looks like this. It's a square root, but you put a small little 3 above the check mark. Square root, but you put a small little 3 above the check mark. Now, how do you evaluate that on your calculator? There's a couple different ways, and I found that one of the easier ways is to do an exponent. So what I would do on my calculator is press the button that looks like this, x to the y, or you might find a button that says this, has a little caret, which means power of. So what I'm going to type in my calculator is this. I'm going to leave that number that's in my calculator right here. Then I'm going to hit the x to the y button. And then I'm going to hit parentheses 1/3, 1 divided by 3. The reason for that is because when you have a fraction in the exponent, the denominator is called the root. So that's the same as taking a cube root, it's just raising to the 1/3 power.